All right, so I'm just going to write on this. That way y'all can actually see my questions. All right, so the first one wants me to state whether this growth or decay is linear or exponential and answer the questions. So remember, if it's linear, it goes up or down by the same amount. If it's exponential, it goes up by percentages. So this one goes up by the same amount every year. So this would actually be linear. So you would come in here and check the linear. And then they want to know what the house will be worth in 5 years. So let's see, it started out at 130,000. And it's increasing, so that's going to be a plus. And it's 1,700 per year. So let's see, they said 5 years. So we take that 5 years and multiply by 1,700 per year. And once we do that, we'll actually get the value of this house in 5 years. So you multiply the number of years times the amount it's going up a year, and then add that to the 130,000 that we started with. All right, y'all, so here we go. We got 130,000 plus 5 times 1,700. So when we push that in, we get 138,500. So we would put that down here. Now they already put the money sign for you, so all you got to do is put in the amount. All right, so number one, linear. Number two, the population of a town is increasing by 609 people per year. So once again, it's the same amount every year. So this is going to be linear. So they want us to tell if it's linear or exponential. And then they're telling us if it's 1,600 a day, what will it be in 5 years? So first, we definitely got a linear. So we click linear. Then to figure out the population in 5 years, once again, it's increasing. So we're going to be adding. So let's see, we're starting with 1,600 plus 5 years times the amount it's going up a year, which is 609. So y'all, let's multiply that one. 1,600 plus 5 times 609. All right, when we multiply that out, we get 4,645. And then just put that in that blank. All right, so any questions on them two being on the linear? All right, let's let one in. All right, so this number 3 says, during the worst periods of hyperinflation in a certain country, the price of food increased at a rate of 10%. So now we're talking percent, so we know we're going to be dealing with the exponential. So we got to tell whether it's linear or exponential. And then it says if our food bill was 100 in 1 month during that period, what was it 3 months later? So that is definitely exponential because we're talking about a percent each month instead of, see, linear, it's always the same amount. But when it's a percent in exponential, well, the first month you're taking 10% of 100. The second month you'll be taking what, 10% of 110. So the percent stays the same, but the amounts will get larger every month. So to figure this one out, we got to go by the months. So they said, what was it 3 months later? So we got month 1, month 2, and month 3. So in month 1, we're starting out at 100. And we're going to figure out 10%. Now remember, 10%, you got to make 10% a decimal by moving it left. So that's going to be a 0.1. Now you can put a 0.10 if you want to. So that's going to give us the amount that's going to go up after the first month. So we come in here, calculator, 100 times 0.1 gives me 10. Okay, which means at the end of that month, you have $110 you're paying for your grocery bill. Okay, started with 100, it went up by 10%, so it ended at 110. So month 2 is going to start at that 110, and we're going to figure out what 10% of that is going to be. All right, so we take our 110 on the calculator times 10%, which is 0.1 or 0.10. That gives me $11. So that month, see, the first month it went up $10. This month it's going to be adding another 11 to that. So 110 plus that 11 means we now at $121 a month for our groceries. All right, then we start at month 3 is going to start at the 121, and we're going to figure out 10% of that. So we take our 121 times 10%. That's going to give me $12.10. Remember, we got to add that $12.10 to our 121. That's going to give us $130.10. I mean, $133.1. Remember, 0.1 is like 10 cents. So now here's where we got to be careful. It says round to the nearest dollar. So that means they do not want any decimal points on this answer. Okay, they don't want any cents. They just want us to round to the nearest dollar. So that 133, since the decimal behind it is a 1, we do not round that up. So we're going to keep that 133. But y'all, the biggest trick on that is pay attention to how they want you to write these answers. Some of them, they want the nearest dollar. Some of them, they want the nearest cents, which would be 2 decimal places. All right, so exponential is the trickier one of the 2 because we got to figure out these percents for every month. So then this one here says, price of a computer component decreasing at a rate of 12% per year. Tell me whether that's linear or exponential. And then it says if it costs $90 today, what will it cost in 3 years? So that one's decreasing, so it's going down. And then we know we got what? 12% sitting right there. So since we're talking about percents, this one's going to be exponential. And y'all look here, it says, what will the component cost in 3 years? So we got to deal year 1, year 2, and year 3. So this one's going down by 12%. So we take the starting amount of 90. We're going to multiply it by 12%. So remember, move that decimal left twice. And that's going to be a 0.12. All right, so if I do 90 times 0.12, that's going to give me $10.08 or 10.8. Now I need to figure out the ending amount for that first year. So you would take that, starting with $90, so take your 90, subtract 10.8, and that's going to give us 79.2. Okay, so remember, I got the 79.2 by doing 90 minus 10.8. Okay. Up here, we were adding the percents because it was increasing. This one's decreasing. So now you would start year 2 at 79.2 and figure out 12% of that. So 79.2 times 0.12 gives you 9.504. So to get the next number, I'm going to take 79.2, subtract 9.504. That's going to give me 69.696. So I did 79.2 minus 9.504 to get that answer. All right, so I'm just leaving all my decimals until I get to the final answer on this, and then I'll round it how they want us to, okay? So y'all, year 3, we're starting with that 69.696. We're going to figure out 12% of that. So that's on the screen. So times 12%, that's going to give me 8.36352. All right, so to get this last one, I'm going to take 69.696 and subtract 8.36352. So here we go. 69.696 minus 8.36352. All right, so we hit enter and I get 61.33248. All right, so let's see how they wanted me to round this one. So let me move this paper up just a little bit so that y'all can see the bottom here. So here's the answer. So they want us to round to the nearest cents on this one. So that's 2 decimal places. So let's see. We got a 0.33. After the 3 is a 2. So I'm going to leave that at 3. So this would be $61.33. So notice this one was increasing, so the amount had to go up. This one is decreasing, so you started with 90, it had to go down, okay? So that computer part they're talking about was only worth $61.33. All right, so I've done 2 examples of each kind. So this one's on y'all. So this one says, state whether this is linear or exponential, and then answer the question. So the value of a house is increasing by $1,900 per year. If it's worth $190,000 today, what will it be worth in 5 years? So first of all, y'all need to let me know, is that one linear or exponential?
Linear.
So definitely linear, good job. Because it's going up by the same amount each year, right? So now, do you want to figure out how much it's worth in 5 years for me? Yeah, and since that was linear, it's not going to be as hard as those ones we had to do the yearly or the monthly. So I'll even look on chat. Y'all got any chats going? Let me see.
$226,100. for the first year.
Oh, okay, so let me show you, Floyd, on this one, you could have done this whole amount. Watch this.
Oh, okay.
Take that 190,000 right there.
Uh-huh.
That's your starting amount, right?
Right.
So you had missed these first two I just went over, like this one.
Yeah.
So you came in on that third and fourth one that was both exponential.
Right.
So on this linear, take that 190,000 and it's increasing. So you're going to add the amount we're about to do. So it said, what's it going to be worth in 5 years? So take that 5 years and multiply by how much it's going up every year, which was 1,900.
Right.
So see, these ones you can sort of shortcut since it's going up the same amount. You can just
Okay.
take the 5 and multiply by that. So push that one in and see what we get.
Okay.
Wait, so y'all getting it?
285,000.
Well, let me see what you're doing. Okay, so get that calculator right here.
Okay.
All right, so punch in that 190,000
Mm-hmm.
plus 5 times 1,900.
Plus,
So I'm getting like 199,000.
yeah, I hit the wrong key. Didn't multiply it.
Yeah, like that zero you said on there, we're getting 199,500.
Mhm.
So then we would put that. What would we get? 195,500. All right, y'all. So this next one says graph these points. So I'm just going to make a little X and Y axis real quick. Now, what I'll do, I'm going to look at one of them real quick and see where it's at, because it looks like they've always got the A's in different spots. So if I can figure out these where the A goes, I can tell the other one's really quick because there's only going to be one with A right on it. So remember, A is 4, 3. So since both of these are positive numbers, it's got to end up in that top right quadrant. So this quadrant, you had to have a negative, positive. Down here, they were both negative. And then this one was a negative, a positive, negative. So watch this. A is 4, 3. So remember, that means the 4, you start at the 0 here, and you go right 4 units. So there's 1, 2, 3. So I went right 4 units. The 3 is my Y. Positive goes up, negative goes down. So from right here, we would go up 3 units. 1, 2, 3. So that point should be right there where that third one went. So I'm looking for an A that's on the right side. So that A is in the wrong spot. That A is in the wrong spot. This A is in the wrong spot. But look at D. That A is over 4 and up 3. So now that I know A's right, look at B. B is negative 8, 3. If it's negative, it should be in this quadrant right in here. So look at here. Negative 8, up 3, there's the B. C was 1, 0. So that would be just right 1. Since the Y is a 0, you stay there. So if you look here, C is right 1, and it stayed there. And D is negative 2, 1. Well, that one should also be in this little section because it's negative and positive. So let's see, down here, negative 2, up 1, there's my D. So the only one it could be for us would be the D on that. So remember, the first number, left or right. Left if it's negative, right if it's positive. So the X's are positive this way, negative that way. And the Y's are positive up and negative going down. Okay. So you'll have 4 pictures. You're going to have to see which one has your right coordinates. All right, so let's see. Number 7 says, in the following situation, state whether 2 variables are related in a way that might be described by a function. If so, identify the independent and dependent variables. So it says you're taking a road trip in a car and want to know how far you've traveled at various times during your trip. So you're looking for the distance we travel. And we're going to use time to tell us how far we've been. So remember, independent and dependent variables. Independent variable, we can pick any amount. Dependent variable depends on the independent variable for its amount. So in this case, let's see, looks like our independent variable is going to be the time. Okay, time, if you got time involved, it's usually going to be your independent variable. Because I can change my time, right? I can say, well, how far did I travel in an hour? How far did I travel in 2 hours? So see, you can change that part of what you're asking. But the distance in its formula, distance is going to depend on the time to get its answer. So that means distance would be our dependent variable. So we want to see over here if one of these matches what we got. So independent variable, they said, was distance traveled. No, independent variable is going to be the time. So let's see, independent variables, time. Dependent variable, which we said was distance traveled. So you want to choose B on that one, okay? So remember, let's see what this one says. Write a statement that expresses a possible function between the given variables. Weight of a bag of candy, price of the bag of candy. So they've already pretty much gave us the 2 variables, the weight and the price. So for y'all, which one of those, weight or price, would you pick as my independent variable?
Yeah, price.
All right, so let's see. No one's putting no chat out. So Floyd said price was the independent variable. So let me ask y'all this. Which one of those 2, price or weight, depends on the other one for its amount? So that would be the weight. There you go. So the weight depends on the other one, right?
Right.
So I think I got you a little backwards. So wouldn't you not think that the price depends on the weight? Think about this. You go to a candy shop, you buy 1 pound of candy, it's going to have a certain price, right?
Right.
If I buy 2 pounds of candy, it's going to have a different price. So your formula would be so many dollars a pound times the pounds to get the price, right?
Right.
So that means, Floyd, that the price of the candy is going to be the dependent. And then the weight's going to be the independent. So you did all right on that, didn't you?
Yeah.
So what one of these would be the truth? As the price of the candy increases, the weight decreases. As the price decreases, the weight increases. As the weight increases, the price increases. As the weight decreases, the price increases.
C.
C, definitely. Alrighty, so that'd almost be like doing your paychecks, right? You get so much an hour times how many hours you work.
Mhm.
All right, y'all, so we add another one of these. So let me pull that up. So write a statement again if it's a possible function. Number of motorcycles on the road, air quality. And they just want you to figure out what's the relationship on that. So I would probably think that the more motorcycles you have on the road is going to deteriorate that air quality, right?
Right.
A lot more pollution and stuff. So we want one that says as the motorcycles increase, air quality decrease. So they got the quality deteriorates. That's wrong. We need what? Number of motorcycles on the road increasing, the air deteriorates. There you go. So they just sort of want you to think about the situations and they're giving you these variables, okay? And remember, you gotta name them in a way that you're sort of letting them know what is your independent versus your dependent variables. So here's a graph that represents a function. So they're giving us the years down here. So years will always be down here on the independent variable, which is the x's. And then your dependent is going to be over here for the average age of death. So it looks like they're going from 1980 to around 2005. And the average age of death used to be about 62 or so. Went up to about 68 or so, because there's the 70 line. So that looks about 68, 69. Then at about 92 or so, looks like we're up to 70 something. And you can see it's sort of going up. Not linear though, because that's not a straight line. Sort of goes up linear at first and then goes off to the right a little flatter, and then it picks up again with a little steepness. But it's definitely not linear because it's not a straight line. So what we want to do is see which one of these might describe what's going on with this. So this one says that function shows the average age of death increases between 80 and 92. So that's the first three dots, and does not change between 92 and 2004. Well, it's still going uphill, so it's still changing. If it wasn't changing, that would be a horizontal line going straight across. But that's not a straight line going across there. It sort of goes uphill a couple times. So let's see, the function shows a steadily increasing average rate of death between 1980 and 2004. So let's see, we got 1980 and 2004. So you want the one that has your right time frame on it. See, this one only had 92. Well, it went all the way 80 to 2004. It just had no change here, and it definitely changed. So this one does look like it steadily increases. So B is a good choice at the moment. C says the function shows a steadily decreasing. Well, if it was decreasing, this thing would be going downhill. And then D says it shows that average age of death per year does not change. Well, if it didn't change all, it would be a straight line going straight across. because it would always be the same age. So the only choice that was good for us was the B. Okay, had a steadily increasing average of age because it always went up. Okay. So in mathematics, what is the purpose of a function? So a function describes how one variable depends on another. A function describes how a domain and range interact with one another. The function describes an operation such as multiplication or division. A function describes how inputs and outputs are affected by machines. So technically, you would go with A. It describes how one function depends on another, just like y'all did on the weight and the price, okay? All right, so I think we can almost see all the 12 there. So write an equation for the linear function and use it to answer the question. The cost of renting a car is a flat $32 plus an additional 7 cents per mile that you drive. And then it says, how far can you drive for $82? So our equation is R is the rental fee. That's going to equal, well, the starting amount is always going to be $32 because you're getting charged a flat $32. And then it says plus an additional, so that's going to be plus 0.07 cents per mile. So that'll be 0.07 times how many miles you go, which we'll use an M for our miles. So we got our equation part. So let's see which one of these has our equation. Let's see, this one has 32 plus 0.07 times M. So that's a good choice. This one has 32 times miles. Well, that's wrong because 32 was your flat rate. This one has 32 minus 0.07 of miles. Well, remember, this says plus an additional 7 cents. So you're not subtracting. And then this one, 32 times miles, that is wrong. So the only equation that matches is A. So now they want to know how far we can drive on $82. So 82 would be what you're paying in the rental fee. That's going to equal 32 plus 0.07 per mile. So y'all, to solve this, you subtract 32 first, because that gets this 0.07 M on the right side by itself. So 82 minus 32 is 50. That's going to equal to 0.07 M. So if you subtract 32 from one side of the equals, you got to subtract it from the other side of the equals, okay? Now, 0.07 M, since we're solving for the miles, at this point, you divide both sides by the 0.07. So we would take our calculator and take that 50 miles or $50 and divide by 0.07. That gives us 714.28 equal to our M. Whoops, let me pull that down. So what you're going to do, you're going to take the amount you want to spend, subtract that $32 flat rate from it. That's going to leave you $50 that you're spending. So divide the $50 by how much it is a mile, and that'll give you the miles, okay? So over here, we picked A because of the equation, and we just verified that it was 714 miles. You know, it's not too bad. You just got to play with these a little bit, okay? Now remember, this is the study guide for my test. I think the test itself only has 12 of these 15 questions, okay? So some of those that you've seen 2 or 3 of, there won't be that many of those on this test, okay? Right, yeah, I think they only made it 12 questions. So do the study guide 1, 2, 3, 4 times if needed, because that's all you really got to do this week. And then the test is due Sunday night, so that'll give you a chance to play with the study guide 2 or 3 times, get really good on it, then do my test, okay? And then the only other thing we're doing this week, Wednesday, I'm going to review y'all for my final. So not a bad week. And if you're behind on any homework, just start catching that up because it'll all close out when the final closes, okay? And I think I got that set for final exam will be due like December 12th, I think. Okay. All right, so this one's we got to think about this one. During the month of January, the depth of snow at the base of one ski resort decreased by 2 inches a day. So it's going to go down by 2 inches a day. On December 31st, there was a depth of 66 inches. Find an equation that represents this linear function and graph the equation. Use a graph to estimate the depth of snow on January 30th. Okay, so all they want you to do really is pick the graph. But what we would do, we started with what, 66 inches. We're decreasing by 2 inches a day times the number of days. So we got to figure out how many days is it from December 31st to January 30th. So what's that? Well, 30 days in January, and then the 1 day from 31st. So what's that? 31 days or so. So let me see if that's what they're doing. So 66 minus 2 times 31. Nope, I think they're doing 30. From the way my answer is. So they're not counting the day it started. So 1 day. So they're going with 30 days in January. So 66 minus 2 times 30. I should have 6 inches. So I knew they wasn't going by 31 because there wasn't no 4 inches down here. So they went with 30 days. So we would go with A right there. Now I'll show you what's neat on these calculators. If I did want to graph that and see what graph looked like, we got 66 minus 2 times. Now on the calculator, you can't use the D, you got to use the X so that it'll graph it. But look, when I graph it, oh, let me fit my window. Let me zoom that in so we can see it. Nope, zoom out, my bad. All right, so you see that line coming down over there going downhill, which they all go downhill, but look, this one has the same sort of slope as this one, okay? But y'all, it wasn't necessary to graph it if you didn't want to. You could just figure the formula out to get the 6. Or look here, this one starts at the 66. This line is going above the 70. This one's going above the 70. So it either had to be A or D because they both started at the 66. But then you remember, you got to take off 2 a day for 30 days. And if you notice, this one was the only one that was coming down. So that 6 is probably right around there. But I done just done the formula. Started with my 66 and then subtracted to get one of them 4 answers, okay? All right, so 14 sort of like a repeat of the one I just did a while ago. We're going to write an equation for this and then answer the question, and it's telling me to round to 2 decimal places. So they got Normaltown High School's record is 100-yard freestyle was 46.70 in 90. Assume that the record falls at a constant rate of 0.08 seconds a year. What does the model predict for the record in 2021? So our record starting at, so R is for record. So we're starting at 46.70. And it falls, which means it's going to decrease. So we're going to subtract 0.08 seconds per year times T, which is time in years. So we know what our formula needs to look like. Okay, so it's falling, so I subtracted, and they said 0.08 seconds a year. All right, so these two are adding, so it can't be A and B. So let's see, C, 4670 minus 0.08 times the T, which is what we got. This one, they're taking the starting record and multiplying by the time, which is not right. So the only one it could be was C, but let's see if we can get that answer, 44.22. So what does it predict for the year 21? So what you want to do is figure out how many years is 2021 from 1990. So I would just take 2021 minus 1990. So that tells you how many years 2021 is after 1990, and that was 31. So what you would do, put that 31 in for your time. Now we got our equation, everything's filled out. So that should give me the record in the year 2021. So y'all, let's see, we would do 46.70 minus 0.08 times 31. Now we know we should get around 44.22 seconds. And look at that, exactly 44.22 seconds. So that's sort of how you can check it once you got your formula. If you got the right formula, it's going to come out to them right seconds, okay? All right, so I'll give y'all this last one because we've done this in our notes for sure. What are the 3 basic ways to represent a function? So I'll even look on chat to see if y'all can. So y'all, A would be the 3 basic ways are table, graph, and equation. B, ordered paragraph expression.
A.
Oh, you done got me. Okay. Table, graph, and equations, all we've been using, right?
Yeah.
Didn't even never talk about an expression. Let's see what they got here. Ordered pair, no, and then expression. So really, we didn't even talk about expressions in this class, so couldn't have been that one. All right, y'all, so that is your review for your chapter 8 and 9 test. Like I said, this has 15 questions. The test only has 12, I believe. But remember, on that test, if it's only 12 points, missing one is going to bring you down quite a bit on those, okay? That means them points are worth a lot more per question. So I wouldn't even try that test until I can probably get a 80 to 90 on this practice test, okay? It'll be the same questions as these. It's just going to be 3 fewer. So, and that's the best way to tell if you're ready for it is by knocking that thing out, okay? All right, y'all, so Wednesday, we will review for the final exam. The final exam will open next Monday, I believe, and it will be due December 12th. We gotta, and what I'm going to go over is that final exam review study guide. So I'll start that Wednesday. If we do not make it all the way through the final exam study guide, we'll do that. Y'all's last day of actual class is next Monday. So that'll be what we do next Monday is just finish that up, okay? And then I'm sending links to this study guide for 8 and 9 and the study guide for the final, okay? Also, if I haven't got your stat project, you got to get them in quick. Because those are due last night, so they'll start losing points for being late, okay? All right, y'all, any questions?
I sent mine yesterday. Did
Yeah,
get
you
it?
should already have a grade for yours.
Oh,
and,
okay.
I think I got Presley's and most of y'all's got grades in there. Look into Math Lab grade book for the grades. I don't know if they trickled into Blackboard yet. So your Math Lab grade book is always the most accurate of all the grade books, okay?
Okay.
Like I said, Blackboard, it takes it time to sync over, and then sometimes it messes them up and it resyncs them, and it's always got issues. It's never syncs to the right grade until at the very end of the class. And then they all will show the same. But yeah, getting to that point, always use the Math Lab grade book.
Okay, I got it.